Manchester, and we're going to hear from Alex and Sam. So Alex is part of Vivacity Labs, and Sam from Transport for Greater Manchester, working on the Smart Junctions project. So yes, and interestingly, yes, working in the automotive industry for the last 35 years, the last thing you need to do is to stop a manufacturing plant. And I think Nissan's probably running at a sub 40-second cycle on more than one line. So the penalties for stopping a manufacturing plant in the middle of a shift are severe. Fortunately, I haven't done that yet, but hopefully there's no time left to do it either. So I'll pass over to Alex and Sam just to have a chat about Smart Junctions.
Perfect. Thanks, Peter. Hi, everyone. I'm sure I'm going to echo many of the speakers when I say this, but it's great to be speaking to actual people, see some real faces and not be speaking at a computer screen. So thank you all for coming out today. I am Alex Yeomans. I am from Vivacity Labs. This is my colleague, Sam Lee, from Transport for Greater Manchester. Just to give you a bit of background into Vivacity, we have developed our own sensor product. We provide a wealth of data to various local authorities and transport planners, enabling them to make more informed decisions on their network. We're currently developing our Smart Junctions product, something which I'm going to touch on very shortly. So, 5G enhanced smart junctions and AI-based traffic signal optimization. Over the last 30 years, we've found there's been significant changes to the transport needs of cities and local authorities, but the underlying technology has very much stayed the same. If we go back to the 90s, the level of automation for the time was very unusual. It meant that the costs and time for recalibration, they were very much accepted. Roll forward to today, where we've got a lot more considerations for things such as air quality, sustainable modes of transport, even more vehicles on the road, which means even more congestion. And we pair that with technology that's very much outdated. It means that the time and costs are very much unfavourable. And that's what here at Vivacity we are trying to solve. We're trying to help cities modernise their traffic signal control. We're aiming to introduce revolutionary new capabilities through optimising for multiple different modes of transport, enabling local authorities to efficiently and effectively enact new citywide policies, whilst also trying to better the current status quo. So through better optimisation, dynamic and adaptive control, and also automating calibration. So you're probably thinking, what exactly is a smart junction? So we have integrated our core sensor technologies that has capabilities to track, count, and classify various modes of transport with a reinforcement learning approach to traffic signal control. Reinforcement learning is reward-based. It's able to improve and learn in the real world. It becomes better, more adaptive, more effective with time. We first start off in simulation. We want to get to a point where we are confident that we can effectively and safely control a junction. Once we're able to do so, our sensors deployed at ground level, they send back just pure raw data to the cloud, so things such as classified occupancy. The cloud is where our reinforcement learning agent sits. It makes a decision based on the data it gets back. It sends back an action to the traffic controller, which is on the ground level. So that's the metal grey box that you see at a junction. And we control the traffic lights, or at least it sounds really simple in principle. There's a lot more tech to it. But that's the high-level 7-minute version, or 6-minute version. So far, when deploying in Manchester at one particular site, we've already seen average reduction in journey times of 23% for motor vehicles. So it's important to note this isn't just in sort of one time period. It's not just looking at peak periods. We're looking to optimize across the whole day for different demand levels, for different scenarios, and it's what we're really trying to aim to achieve. So, as you can imagine, real-time deployments require real-time data. And what that means in terms of connectivity is one that is reliable, it's consistent, and it also has low latency. So far, when we've been deploying, we've had sort of two options, a wired approach and a wireless public 4G one. A wired approach is able to help us solve the problems with reliability and latency, but the costs are very prohibitive. It's just not really that scalable. If we look, on the other hand, a wireless public 4G network, it enables us to deploy a lot faster, it's a lot more cost effective, but you know the issues with the connection become apparent with latency issues, especially in the peak periods, bandwidth problems, sensors dropping offline, So it really isn't great. So to give you some real-world examples of this, and this is for deployments that we've done across Manchester, Peterborough and Cambridge. These are all city-based locations, so congestion, they're very congested. There's a lot of tall buildings, a lot of street furniture, and there's just overall a lot of network interference. In our testing so far, what we've found, particularly in those peak periods, is that there is a lot of latency. We have a lot of bandwidth issues, a lot of sensors drop offline, and it really interrupts that deployments and actually taking control in real time. What we see when we move to using a wired connection is trying to solve these problems. So moving on to this one, and this is where we see 5G and a private 5G network really coming in. We're hoping that it can provide a reliable connection, something that can be easily replicated, causing minimal downtime, and something that really is scalable. Something with low latency, something that's constant, no latency peaks, and where we actually get that real-time data to give us a real-world picture of what's happening at the junction at the time. In interconnectability, so looking into a future where connected autonomous vehicles play a massive role in the transport network, having a network and IoT devices that are able to seamlessly communicate with one another is critical for smooth operation of that network. And finally, looking at a local authority owned and managed network brings about further opportunities and further use case benefits, which hands perfectly over to Sam to speak a bit more about TFGM's.
I think I've got 30 seconds, so I'll paraphrase very quickly. I think the strategic interest for TFGM is the fact that everybody's talking about decarbonisation and green, but fundamentally we can't build additional capacity. 5G is a way for us to reduce that cost and transition the behaviour, not just from the driver side, but how people access services as a whole. I think just to touch on some of the key learnings we learned from a local authority perspective isn't necessarily how just the technology works, is what the potential commercial model looks like for a solution like this. What are the cybersecurity implications? What are the future skill set that we need to consider in terms of telecoms and implementing these equipments? You know, we've been luckily working with SMEs that really want to deploy these solutions in a real world environment that then can be replicated. So creating these blueprints from scratch, it's been really, really challenging, and learning from those failures and hopefully, you know, sharing you guys what we've done and not worked well will be great, you know, after the session. I think the final thing to consider as a whole with this 5G network is we're not looking into just building this for the smart junction use case. It's about building this foundation that we can easily incorporate other innovation technologies, whether or not it's air quality sensor, whether or not it's this private network to provide fixed wireless access to local healthcare so people don't have to travel. It is that complete holistic picture, not just about physical transport, but also digital transport as well. Oh, ran to time. Thank you.